Sure. Well, thanks for organizing this. Thanks for getting such a great set of speakers, and particularly Mike Frank at relatively short notice because of the indisposition of a previously scheduled speaker, and for getting this range of perspective. So I'm going to just float. I listened to all the talks, and really, really interesting. And I think we're finally, after many years, uh, getting to the nub of what is going to be, or what is proving to be, very, very difficult about implementing this on the ground. I think there's very, very strong movements to get it implemented on the ground. And I have a bunch of uh, questions or topics I would love to hear, just general round robin on. And one is, and this is a bit of a hobby horse of mine, is that the willingness to engage in this collective enterprise, and it really is a collective enterprise because there's a theory of change in a sense that says that if individuals contribute to this, just like peer review itself, that somehow the entire discipline will benefit, and therefore we have to make this special effort so that all of us benefit, including ourselves. That's why we do peer review, and that's ultimately why data sharing. That's the justification for data sharing. There's a value to science, and ultimately, in many ways, a value to us. But this is often very, very different field by field, and also the fears are different field by field. And I feel like certain conversations, depending on who's engaged in them, become dominated by the interests and fears and culture of particular kinds of science. So here we heard about psychology, we heard about clinical trials. Um, Jeff Drazen brought in a little bit of basic science. Um, uh, but I think that the dominant modes and issues in each of these areas is quite different. Is quite different. And for example, I think there are big differences in basic science than there are in clinical trials. So this is a difficult question for this panel to ask, because I'm asking you to go outside your own fields of expertise or experience, which is, how do we extend what we have learned in certain fields that have made major efforts in this? And clinical trials is certainly among them. Psychology is certainly among them, to fields that have had much less primary experience with it, like basic and preclinical science, where there is equal pressures right now, where there's real fear of being scooped, and there are other pressures and lack of rewards for doing this. So I thought we'd start with that, and then I'll come back to things that are more specifically related to things that were mentioned. How can we extend this conversation and figure out what makes other fields, incentivizes them, or makes it easy to do what we're talking about? It's a difficult question.
Yeah,
Maybe
Steve,
Jeff?
Ken, maybe I'll jump on it first. What the heck?
Sure.
And I apologize. It took me a little longer to get back, so I missed your first minute of discussion, but I think I understand the gist of what you're getting at. So you want us to look external to our field, but to do that, I need to look
A
internally
little
to
bit,
my
and
field. Yeah,
I'm thinking particularly about basic science, um, where I think the issues are somewhat different. There might be parallels. I think they're parallels, but the culture and the pressures and the balance of interests is often seen quite differently the in in basic science.
yeah, I agree. And I think it's not necessarily specific fields. I think it's the people in those fields. So I had the great fortune of training under and having Rob Califf as a mentor from the very beginning of my clinical research experience. And he really epitomizes the opportunities that you can have on these large programs. One of his unique talents was taking a very eclectic group of people together who all had their own strengths. And we always said our own oddities, but he brought them together to form teams to do really large trials that were impactful. And he showed that no matter what level you were, from a research associate to a fellow to a young faculty, a senior faculty, there were opportunities for learning and academic currency along the way. And I think that what we need to do at places like Stanford, where we are still what I would call an R01 shop, is that people would rather have their own R01 than being a part of a large 10, 20, 30, $100 million grant. We do have some of those now with Jeff Glenn and others, but we need to show people in basic science and other therapeutic areas in medicine that model can be helpful for the individual, but also impactful for the science and the translation of science into the human condition.
So there has to be a field-wide agreement that this will create collective benefit. And we have to find ways to do that. So I see Russ and Ida both have their hands up, but they've had time to ponder this. So thanks, Ken.
Yeah, I just wanted to
in there, and Mike.
I just want to follow up on Ken's comment that what's really interesting is, like, even within neuroscience and basic science, different subfields have totally different, approaches. And I think there is kind of a founder effect, such that you can sort of trace it back to the degree to which that, like, one of the really famous people with the big labs was either like really open and transparent, or really paranoid and closed, and then their diaspora go out and sort of develop the field. So people who do fly neurobiology are really open. People who do mouse stuff, particularly in particular questions, like particular parts of the brain, are much less open. And so I think, part of it is like figuring out how to break that, that sort of founder effect.
Yes. Interesting. Ida, and then Mike.
Yeah, good question, but a challenging one, Steve. I'm thinking about groups that you wouldn't think would share, but do share. Again, just taking lessons from clinical trials. Pharma shares, the Critical Path Institute, they did CSDR before Vivli came on. What is it? I think they've identified a pre-competitive space where they realize that sharing would not threaten their core business, but enhances each of their own interests in a way that was, that was a collaborative. Same thing with this NIH gray thing of the notion of co-opetition. How do we compete and cooperate at the same time? And I think as we move into a world of open, that we need to be thinking about co-opetition and structures of co-opetition, defining spaces that are pre-competitive, where there is more value to share, and yet not raise that sort of, that intense existential fear that Jeff mentioned. And I like that other point about that Jeff was saying, that you work on this trial, and if you don't get P less than 0.05, like that's it. I think we've sort of made it too high stakes. We need to think about what should we be competing on, and what should we not be competing on. And where it is right now, I think the incentives are kind of perverse. But I think if we don't even think about it in that form, then I think we won't be able to carve out a space where we can share safely to the good of all, and leave it that individuals still need to distinguish themselves, and still need to compete, and still need to stand out.
Interesting. Thanks. I had never heard that term before. That's a great term. Now I'm going to start using it.
Yeah, it's quite a thing.
Mike.
Yeah, thanks. This is all interesting. I guess the framework that I think about kind of encouraging data sharing in and encouraging kind of broader openness reforms in is similar to what Ken was talking about, which is an incentive compatible framework, trying to think about what can't be done in a field unless you get data sharing. And so, this is easier said than done, but I think the kind of anchor experiences really can move a field forward, where you see a piece of science that simply wouldn't be possible without a very large collaborative effort, without people opening their data sets up. Just to take one example that I think is thought-provoking from a field that's pretty far from mine, there's a recent paper that made a fairly big splash last summer on assessment of energy expenditure in human bodies across the lifespan, kind of creating a new model of metabolic energy expenditure. I know nothing about this, but I read it with interest because it was a case where there's a whole bunch of labs that use this extremely expensive doubly labeled water technique to try to capture energy expenditure. But because it's really expensive and requires a lot of sensors and so forth, they do it on very small handful of participants. And recognizing that need, all of these labs got together and started pooling data, creating an open data repository for each of these populations. And eventually they really hit kind of critical mass with the number of participants that they had, and were able to start fitting newer, better models. Because getting a real lifespan model of how this changes from tiny little babies to aging adults is much more data intensive than any of the individual studies. So these kinds of opportunities to create the kind of field defining high profile paper, whether it's a brain atlas or a model of energy expenditure, these sorts of things, I think, are the drivers of real culture change, and looking for those opportunities where you can do something. It's not just, hey, let's check this box on the grant compliance, but let's do something new. Let's do something that really motivates us from the basic science perspective. That's what I find inspiring. And I think others respond to that. They say, oh, well, maybe there are other opportunities. Maybe I could be the one to kind of help in this project. Maybe I could get my name on this giant, awesome paper that is really going to change the way we think about this particular area.
But that's a spectacular model. Of course, it's one you've been promoting, but let me just dig a little deeper there, which is, we've heard many theories about what the primary purpose of data sharing is. So you've articulated sort of the highest purpose, which is we'll bring together all this data to create new theories or to test new theories in ways we could never do it before. And of course, that's the model for many data sharing enterprises. But there are other sort of more primitive and basic goals, which is simply, and Ken sort of reflected on this, one of the primary ones is, let's just open up the data so we can confirm what somebody else said, computational reproducibility or sort of transparency. And then the second level one is that we're going to publish another analysis of a subset of that data, like we get from large cohort studies or clinical trials. We'll publish one of those secondary papers that the primary authors could have published, but they didn't get around to it, or they didn't have the inclination to do it. So this other group will benefit from that. So the first one is sort of confirmation, simply confirmation, which actually I did want to ask Ken. He said he didn't really want people going out and digging into their data just to redo their own analyses, but in fact that's the articulated purpose for a lot of data sharing. The second one are secondary analyses, and the third one is to literally amplify science by combining data sets in a way. And each one of these would seem to have different structures and pressures and incentives associated with them. And I think part of the difficulty is that a lot of the articulated purpose is to increase confidence by sort of checking on the reliability, or secondarily to make better use or more complete use of the data by publishing analyses that the primary authors would never have either gotten around to, weren't thinking of, or wouldn't have gotten around to, or wouldn't have gotten around to as fast. So I would love to hear some discussion of those sort of less high-minded goals for data sharing. And again, Ken, you said you didn't want somebody sort of mucking around in the data set to do something less well than your expert team has already done. And this gets very close to the issue around harassment. You don't want to be constantly badgered by analysts who you think, and you might be right, might be doing something that isn't being done as well. It won't be done as well as what you already did, but that runs contrary to the motivation of reusing data to confirm it and increase confidence.
Yeah, thanks, Steve. And obviously, I was being a bit provocative when I said that in my brief
you provoked
comments.
me.
And
You're successful.
I poked the bear. I poked the bear. I think for me, there's two issues, right? One is people may actually use the same data in the appropriate way, but use wrong statistical methodologies and come up with inferences that just aren't right. The other challenge that I see is what Jeff dove into quite a bit, and that is that these, at least in my world of these large clinical trials, these are complex data sets. And there are a number of assumptions, censoring, and other things that happens to them that even with incredible documentation, with statistical analysis plans and protocols, you literally can't replicate it. And for people on the symposium here, when we do these 10, 20,000 patient clinical trials, and others who run these know this, we actually have statistical groups from the academic center and the sponsor that are literally working for probably 6 to 12 months before the trial's even done, making sure that they're matching, not on the treatment effect, that's still blinded, but just matching on events and follow-up and key parameters. It can get really complicated. And when you're now starting to talk on the basic science side about genetic data and all sorts of other data with deep phenotyping, those could be complicated data sets as well there. And that's why I really think what you need to have important governance and stewardships of the data. And so I know Elliot well, I can understand kind of feeling harassed, but I also think there may be reasonable harassment that you have somebody who wants to do the right thing, that really just wants to replicate what you did and show that you were right, but can't do it without you becoming engaged at that level. And that takes time, effort, and money. And we're all on to our next projects. We got to figure out a way that we can do that.
Actually, that leads to, Ida, you want to chime in there? Great.
Yeah, I think it's helpful to think about what the objectives are there. One is the whole reproducibility thing, and how that's a core, sort of, it's a foundational practice of science, not the eventual outcome, but sort of part of what we need to do. I think fewer than 5% of the requests at Vivli have been for reproducibility. Doesn't seem something that people want to go out and do. It seems like a housekeeping kind of thing. And I wonder if we shouldn't be thinking about reproducibility sort of as a housekeeping thing, that it's part of the data stewardship. It's part of how we manage our data and how we ensure that our studies are done well, that reproducibility sort of in some sense falls out of it. And just sort of park that aside as some other kind of process thing that we need to do to ensure that the production of science. And I don't think that's enough to get people to want to share. That just isn't. I think it is going to be the fundamental value of either new insights or making science, better, like findings that allow us to make the next study better. And I think the issue there, Michael, great to hear examples from you from specific disciplines who've gotten together. I think the issue is scale. Like, how do we can't just wait around for like a specific group of investigators and some, amazing person comes through and, is a nidus for data sharing. We can do that, but I think science, we're thinking about sharing at scale, and science is now very interdisciplinary. We want to foster science that crosses disciplinary bounds. And we aren't going to have that when, everyone who's working on this topic, can share. That excludes people who aren't known amongst those who are kind of in the know. And so I think we need to think about incentivizing and building structures for promoting discovery at scale, and how do we do that? And maybe park aside the issue of reproducibility as a process goal that we should maybe get at in some other way. maybe.
Mike?
Yeah, I guess I'm a little more radicalized than I think the two of you are about reproducibility. All of these endpoints, reproducibility, replicability, and so forth, are very heterogeneous across study populations and field populations. But in psychology, we're sufficiently sloppy that I think if we don't have reproducibility as a key goal, many of our papers, much of our core science will be undermined by poor statistical and data processes. I know this because I've undermined my own work with such processes in the past, and I'm under no illusions that I'm, the right processor of data, and I get it right all the time. Copy and paste errors happen to everyone, and they have been part of high-profile retractions, high-profile changes in policy. So I guess I think that reproducibility is if we think about our goals, encouraging reproducibility is absolutely a critical feature of shoring up the scientific enterprise. Now, the question is then, if we want the data accessibility more generally, how to get there? And that's, I just to kind of re-articulate Steve's question, that seems like a policy question. We want behavior change and culture change, and we're trying to figure out what sorts of policy levers we have accessible to us in order to make those behavioral and cultural changes. One policy lever we have is mandates from funders and journals. We have some of those. They don't work that well. My data are just kind of one example of that. But for example, Science's data sharing on request policy, it was roundly ignored by many folks, right? So journal policies on, for example, the American Psychological Association's ethical guidelines suggest that data sharing is required on request, that those requests go unanswered something greater than 3/4 of the time. So right, just pure policy shifts don't work, but mandates with teeth may be important. But beyond that, I guess the reason why I'm talking aspirationally is because I think culture shift requires not just mandates, especially not just unfunded mandates. It also requires, didn't talk about this much, but technical tools that make the behavior and compliance easier. So Russ has been a huge leader in this by creating standards and validators and shared analytic tools that kind of provide value for data sharing. And then finally, you got to make it cool. Culture change requires making the target behavior a norm and one that people are excited to participate in, or at least that's a very good lever. Just to take a little bit of psychology here, when we try to do anti-bullying interventions, right? There's a literature on anti-bullying interventions. And one of my favorite findings here is these interventions work okay, but not that well. But when they really work well is when the cool kids do them. That is when the cool kids go out and they hand out the bracelets that say, don't be a bully. And they talk about the principles of the school, sharing and kindness, right? That actually is really what does it, what makes the behavior change. When you want people, to change their behavior, you look for role models. That's the psychology thing. And so that's why I'm saying, hey, we got to do these high profile, beautiful studies that lead the field in terms of their use of open data sets, because when it looks cool, and when you nudge people with the technical tools and the mandates, that's when you're going to start to get that confluence of carrots and sticks that leads to behavior change.
Interesting. Okay, Russ.
Yeah, I want to follow up on that. So I'm involved in this, the kind of main conference we go to is the Organization for Human Brain Mapping. And for a number of years, it had sort of what we call the open science room, where I think, at first it was the geeks who hung out there, but then they became the cool kids. Probably about 4 or 5 years ago, when it was just starting to become a big thing, one of the really kind of famous senior people in the group complained to someone else and was overheard complaining that the open science zealots are taking over the organization. Fast forward 4 or 5 years, this person has now become an open science zealot because, it's like the organization is now just totally suffused with with people who think that open science has big value. And so I really view kind of professional societies as an important place for this sort of thing to happen. And certainly I think that's where part of, what I was talking about earlier, how different subsets of neuroscience kind of have different philosophies. And these are often people who go to different conferences, and it really sort of falls out of that. Also want to highlight, that, going back to this kind of open by design issue. I think Jeff raised this very early on, that making data sharing sort of as easy as possible and making it not be a huge step from what you already do in the research, I think has been really important for us. Like we've given people tools to organize their data, that, and I think one of the important kind of levers for sort of persuasion has been this idea that, like, when you have data and you want to go back in a year and look at them, you're effectively a different person. And so even if you never share your data with the rest of the world, having them organized in such a way that they're ready to share makes it much easier for you or one of your postdocs or someone to come back and actually look at the data later. And that's been I think a good kind of persuasive argument.
Well, that leads in to another question, which is, we're talking about stimulating collective action, and yet we're talking about a lot of models to do that involve individual actions and individual decision making, which is a very inefficient way to induce collective action. So I want to bring into this the policy that was developed at Packard, and nobody mentioned that. That was something I was involved in at the beginning. They have a mandatory data sharing policy. It took them 3 years to develop it. And they did this with a pilot by also vetting. They did a variety of things that I want to toss out there. First of all, they have approved repositories. And this was only, and it's several of them, and some of the people will be familiar with several of them. One is the Michigan, I think, social science database. I forgot the exact name of it. That has like, yeah. I'm sorry, what's the name of it, Ida?
ICPSR.
Yes. And they do a lot of, and I'm sure Vivily does this and other repositories, sort of pre-processing to make sure that the data that they're getting is actually analyzable and has the adequate metadata. So they have pre-approved databases. The second thing is you must submit the data package, and they have a defined parameters for what is a complete data package. And again, I think Ida probably knows a lot about this sort of thing, that you must submit at the end of the funding period, when you submit your report. At that point, it is out of the experimenter's hands. So if they want the money, they want the final tranche of money, they need to submit that. When it goes into the repository, the decisions about access are out of the hands of the investigator, but they're still adjudicated. There's a small panel of both researchers and lay advocates or patient advocates who are a team of 5 who helps decide on the release. And there's specific criteria around what's a legitimate request. It has to have a formal analytic plan, hypothesis, etc. You can't just download it for no purposes at all. Although I fought a somewhat losing battle to make them available for teaching purposes. But you could submit for teaching purposes, but you'd have to be very, very specific about that. And the final thing is they actually pay for this. So they tried to price out what it would take to prepare this. And one of the biggest challenges, which I also heard discussed, is you don't want to pay somebody more to do what they should be doing anyway as part of good data management. So you shouldn't be rewarding people for bad data management. And they say, well, it will cost me, another $100,000 to prepare to do it right. But it is fair to have a reasonable price for producing what they call a complete data package and delivering it. That actually is the kind of thing that a typical researcher will not necessarily price into their research budget. So they do 3 things. One is it's deliverable at the end. 2, the decisions about sharing is taken out of the hands and out of the hair of the researcher. 3, they do have protection against we'll call it spurious or worthless data sharing. And I wonder if this model, this is nothing like this is part of the NIH requirements. So, but of course NIH covers a much broader range of research. So I'm wondering what of those elements you think could be adopted or could be implemented by either other funders or other entities, and to facilitate this, so it's in a sense out of the hands of the researchers. It's no longer their choice anymore if they want to accept public money. I'll ask a companion question. You can both consider the other. The other is, if we, at the complete other end of the spectrum, if we want to incentivize this in academia on CVs, induce, say that you get more credit for promotion, what are the key elements that you would feature? This is something that we have a project at the SPORE, the Stanford program on research reproducibility in the School of Medicine. We have a small CV working group to try to feature those elements that will that people can so we can recognize these activities, and then of course a promotion committee can choose to can't reward what they can't see. So what do you think are the most important activities to feature to provide incentives at the other end? So I'll ask both of these questions simultaneously because they're actually closely connected. Jeff, you're muted.
Can I answer the question about the incentives? I think the Gates Foundation is a good example. When you sign a contract with them, you sign a contract which says you're going to share the data. They're actually going to provide the methodology by which it needs to be shared. And still they have a problem with it. For example, they do many of their studies in Africa, and there the governments don't want the data to be shared because there's been this problem of what they call parachuting investigators, people coming in, taking the data in. And so there are, in fact, sometimes legal roadblocks, but I think it has to be the funders. They're the ones with the teeth, and not editors. Editors have the teeth with respect to trial registration, because at that point, it was what was going to be published. But I think that it really lands in the heart of the investigators and where the money comes from. That's why I applaud the NIH. It's going to be interesting to see who takes over at the NIH and whether they really enforce this. There's been a lot of things that the NIH has required that haven't actually come to pass. And if the NIH says no shared data, no money, and they have a couple of examples like that, money taken away, Duke suddenly doesn't get $10 million they thought they were getting, that'll change everything. But it hasn't happened yet.
Although the NIH policy is not that right now. I think they'll be pretty tough on data management plans, but they are explicitly saying they're not going to enforce data sharing. One other thing on the data that can't be shared, PCORE has a carve out for if there are particular legal or other privacy reasons why data cannot be shared, you can submit those reasons up front and basically have them approved or not, because again, it becomes out of the hands of PCORE and it becomes out of the hands of the investigators henceforth. So they make a determination. So if there are legal reasons that the country wouldn't allow certain data to be used, then that would be a carve out. So we have talk about incentives, academic, and funder, the structure of funders requirements. Michael.
Yeah, you were discussing the sort of hiring and promotion type guidelines. I have to say, I don't know if anybody else on this call is like me, but I probably spend a significant amount of my funded effort reformatting my CV for different requirements. Right, every time I have to write a letter of collaboration, there's like an hour worth of reformatting. And Science CV and the various other NIH tools have been used for this kind of purpose. So it seems to me like asking for fields like data set DOIs and kind of registration identifiers in those, and making them play a more prominent role on these standardized formatting instruments, or sort of standardized formats for that are required for most instances of kind of hiring and evaluation, would have a significant effect. Like if there's just a field you can't fill in on a thing, and you notice that like a bunch of your fields are empty, I think that's going to make a lot of us field fillers for a living feel a little bit, inadequate. So I think that on this side, the paperwork might actually be kind of useful, or some paperwork.
Yeah, interesting. Ida.
Yeah, I think we're moving to a world where data itself is an asset. We're used to thinking of the publication and we know how to manage that, but the data itself is an asset, and it's an asset that you need to husband appropriately. And I think we still don't really know how to do that. We don't understand that data is a strategic asset. And so then we kind of run around and, share it. There's a lot more to it than that. I know, like the Gates Foundation, it does require sharing, and they have money to share, and they have grantees that can get at the money, and they still don't share, right? And the NIH, I think, what have I heard from them? That they're not sure that they know how to evaluate the quality of a data sharing plan. I heard that's why they aren't putting it into the scientific review process. Maybe they don't know enough right now to say how it should be shared. That's the whole point of the Gray initiative, is for us to figure out how we should share. And I think there was reluctance perhaps to mandate something, like getting ahead of itself, I think. But I think our science paper was like, it's ample time to quote unquote get ahead of ourselves. If you mandate it, then you rally the troops around to figure out, what we need to do but if you don't have a mandate, then we're always waiting. It's very much a chicken and an egg problem. I think that's kind of the loop that we're caught in right now.
So the other entity that can induce collective action are institutional leaders. And Mario Milichki asks a question in the chat related to, leaders saying, have something as draconian as a contract for researchers that basically requires them to share data if they are part of that institution. You don't have to have statements quite that strong, but what do you think? And I know that there's been an initiative nationally from the national academies that is enlisting the role of leaders, that I know Russ has been quite involved in at Stanford. What do you think the role of leaders are, either at the institutional level, or the school level, or the departmental level? How can they help, and what can they materially do, other than just make declarations of values? Russ, is that what you wanted to say?
Yeah. So that's exactly what I was going to raise. So there's this group that was led by the National Academies, and Greg Tannenbaum, who I think dropped off the call, was one of the leaders of this, that has been meeting for a couple of years. There's actually a report, I'll dig it up once I've done talking and post it. It was called the Leadership Initiative on Aligning Incentives for Open Science. And basically it was trying to address exactly this issue of how do we change from the top. They had these like phone calls in the beginning. Once they asked me, what do you think is the one thing we could do to try to like fix the incentives around open science? And my answer was, force everybody over the age of 50 to retire. Because I think that's the big problem, right? Most of us who grew up in a very different world are the ones who are making decisions about hiring and tenure and promotion and stuff. But that's the goal of this group, is to try to figure out, like, how do you make that move? And so what they're doing, there's going to be a meeting later this month where this thing will be sort of announced to the world, and a bunch of organizations, including Stanford, have come together to basically say, we have a presidential level commitment to making open science part of our of how we think about what makes for good scholarship. The challenge is, at places, organizations differ in terms of the leverage that the leader has, right? At Stanford, if you want anything to happen, the president can't just say it, right? The provost can't just say it. It has to go through the faculty senate, and that's the Wild West, right? And it's mostly people who are, of our vintage, right? Who didn't grow up in a world of data sharing, and a world where data was a first class research object that should be treated as importantly as a paper in Nature or Cell or Science. So I think that that group is going to be trying to address this up front, but there are these kind of structural challenges that just make it really difficult to to go from the president saying, hey, we want to make open science a priority at Stanford, to actually having policies change.
Are there as part of that initiative, are there suggested routes for implementation of that vision?
Yeah, well, that's exactly what we're going to be working together on. So basically a bunch of, the presidents aren't going to show up for the meetings, but people like me who are representatives of the presidents will mostly show up at the meetings. And the goal is to basically sit down and figure out what are the ways, what's the menu of potential options that one could use to try to make this kind of change. And then how will those different things work in different types of organizations? And that's, I'm guessing that's going to be a 1 to 2 year process going forward before we have anything to sort of offer to say, hey, here's our blueprint for how to make institutional change happen.
Yeah, interesting. Ida, and then Ken.
Yeah, 2 comments. I think at UCSF, we decided after internal deliberation that the IRB will lean heavily towards data sharing. That all IRB protocols that come through, the default is that anonymized data will be shared, and that's that. And once it's de-identified, it is out of the hands of the IRB, so you don't have to be afraid. And the first pushback was actually from the people within the IRB, right? Because that's why I was bringing it up. It's like you have different proposals and you're getting different feedback on whether you should or shouldn't share. So I think it's sort of internal norm setting is important. And I think culture change happens at different places, and it all comes together. And I'm kind of thinking, and maybe Jeff has reflections on this as well, and Steve. We went from no way in whatever that trials are going to get registered because it's a big threat, to all right, trials can be registered, and then there's no way in heck that we would actually share summary data, right? Or we're no way that we're going to share our participant level data. And I think when the IOM committee got convened, it was really pretty clear around the table. We had industry people and academics and whatnot, that it wasn't a question of whether anymore. It was a question of when and how. And like how did that happen? I'm not quite sure, right? These things sort of evolve over, and I'm not quite sure how that happened, but that might have some lessons.
Thanks. Ken?
Yeah. Obviously there's no one answer to figure out how to activate this kind of research in our individual campuses. We're all kind of coming up with little things to tweak. Ida just said the IRB, and I think Jeff previously was the one who talked about promotion processes at our institutions for people earlier in their career that have a phenotype like me, that maybe haven't landed big grants yet, but have learned a lot on large programs and written secondary analyses. And I think that we need to do a better job of recognizing the academic importance of those manuscripts. And Jeff, I assume you were talking about the Harvard experience when you gave your examples. At Stanford, it's clearly a problem. People like Bob Harrington and I have to go to these committees and either write letters that really support that these people are truly worthy of promotion based on what they've done already, and there's still incredible pushback. So it'd be nice to hear a bit about that. Steve, maybe this isn't a rabbit hole you want to go back down again, but if you do, it'd be great to hear more from Jeff about the Harvard experience, and then Ida as well, because we're struggling with it here. Unless we fix that problem, open science is, for at least the clinical investigators, not going to be a viable strategy for spending your time and learning and excelling.
Jeff, did you want to respond to that?
Well, I think I said what I said, and I agreed with, I think it was Ida's point that you just need to get everybody over 50 to get off those committees. And I'm 75, so I'm way over. But I think that it's ingrained, and the committees are small, and someone makes a statement saying, all he did was recruit 50 patients for this study, and he did that 10 times. So That didn't require any thinking or any new scientific effort. But anybody that's ever tried to do it, to recruit patients and keep them in a clinical trial, and that's how we get the answers we need. You know, you can't win a World Series unless every single position is played by someone who's good at it. And we're only rewarding the guys that hit the home runs. Doesn't make any sense. And so it's a culture change, and it has to be led by the deans. And they're going to have to go to these committee meetings. And when somebody speaks up like that, they're going to have to tell them that they're wrong. That's it.
I have a follow-up question for you, Jeff, which is a little different, but I think it was during your tenure that the New England Journal had that competition for reuse of data for a couple of specific trials that you had published. What did you learn from that?
So that for people who don't know, we took the SPRINT data, which was the study of lowering systolic blood pressure in older patients, people over 55, with either a goal of 140 or 120. I think I have the numbers correct. And it showed that the lower systolic blood pressure was associated with fewer adverse cardiac events. And we published it, and we said, taking the data that were published, teach us something that we're new. And we gave people access to the data set once they had approval from their IRBs to so do. And it was interesting. There were a lot of other secondary analyses that were done from that, some of which have been published, not in the New England Journal, but elsewhere. But so there were no great revelations that were in the data. One, two, we discovered that there were errors in the data as they were posted. And it turned out that there were some mistakes. It turned out that they were not substantial mistakes that changed any of the outcomes, but it wasn't quite right. And by making the data set public, we got it right. And so I think it had that as a benefit. But there were, as I said, there weren't any major new things that were discovered.
Yeah, but that was a high profile sort of deluxe.
Right, and actually one of the most interesting things is that the people who did well in that study, the guys who came in, a woman who came in first in Israel, she's been leading all the vaccine evaluation studies. The guy who came in second led the group of BU medical students, is now a cardiology fellow at the BI. And so they took people who weren't sure about research careers and really got them interested in research. So to me, it had that as a benefit.
Interesting. So I'm just going to ask one more question, but the last one I'm actually going to hand back to the panel is that are there any questions you would like to tee up or issues with the other panel members? And the very last question I'll ask, and we don't have to spend much time on this, is we talk about, and this was alluded to by a couple of you, data sharing as though there's an object that we just have to release. But of course, once you get to an analytic data set, 90% of the choices have already been made that one could contest. And a lot of the variability in science comes from the choices that you make in going from that raw data all the way, boiling it all the way down to that analytic data set. And the question is for some of the purposes of data sharing, not all, getting some insight, and Russ is certainly a pioneer in this area in fMRI, is that if you just look at the data set after all these analytic choices have been made, you're missing the whole ballgame. So how do we come to consensus on which data is the right data to share to achieve some of the goals of data sharing? Because it's easy to, sometimes to share that analytic data set. It may just be a gigantic data file, flat file, but to communicate what brought you from the beginning of your journey to that point is infinitely more complicated. Any thoughts on this? So Russ.
I think it's going to depend a lot on the complexity of the pre-processing that goes between the very raw data and that analytic data set. For fMRI, there's a ton of flexibility in what happens between those two steps, and I think that's why in part why we saw such variability when you give people the same data and have them test the same hypotheses. and I've got, obviously there's a lot of, areas of biomedicine, genomics, things like that, that any sort of omics that have that level of complexity. I don't know what the complexity looks like on a clinical trial. But you can imagine, trying to figure out what the important levers are, and potentially, if not releasing the raw data, at least release kind of like what we've come to call a multiverse of pre-processed data sets, right? Where you basically say, we're going to take the raw data and give you 10 versions of it that have been pre-processed in these 10 different ways that you can then, and one of them is the one we used in the paper. These are other ones that might have been used, and you could, start asking about, vibration or, whatever you want to call it, the differences in the results. That's certainly the way that we're thinking about it in the fMRI world now.
Well, in clinical trials, there are all sorts of areas of judgment, endpoint adjudication, exclusions, eligibility. Ken can speak to this if he wants to. There are many things where the crux of the whole thing is ascertainment of the cause of death. That can be a very, very big deal. And people, the COVID debates have made, some of the public debates have made that particularly public. They dying from COVID, with COVID, and unfortunately they've used that to undermine credibility in certain statistics. So there's definitely complexity in clinical trials. I don't think at the level that occurs in fMRI, but absolutely there are judgments made before that number appears in the data set. Let's see, in an ideal, so Mario, which has chimed in on this, says in an ideal world, code sharing would capture the data cleaning process. Shared data would be the uncleaned one. However, in practice, researchers don't clean data with code, and including myself, find it easier to just edit the data manually and create the final clean data set, and that is indeed a reality. So unless somebody wants to chime in on that, are there any other issues or questions that any of you would like to raise for your fellow panelists, or things we didn't touch on that you just want to make sure, sort of a final word on this issue that that you'd like to leave us with? Either one.
Yeah, I'll bring up one issue about which part of our scientific enterprise is going to drive data sharing and open science. I think we can take some maybe lessons from trial registration and how it ended up sort of devolving in some sense to the legal and compliance side of the university. And I think that would be a really big strategic misstep to have this NIH, data sharing policy be run out of the regulatory compliance side of our research enterprises. I think this is a scientific opportunity and not a check the box one. And we've talked a lot about who needs to lead, but maybe should we also think sort of in some sense defensively who should not be leading this, and how do we make sure that that doesn't happen? Because I think it's going to be easy enough to say, just hand it to the lawyers, hand it to compliance people, and then there'll be a box, and and then the box would be checked, and it would not be reusable at all or interoperable. But hey, the box is checked, and I think that would really be a real shame. That's
a really, really interesting point. We're actually involved in something a little related to that right now, so it's a great point to take home. Anybody else before I hand it back to Russ to close the meeting? Ken, Mike, Jeff, any final words of? Jeff, I see you unmuted yourself.
It's not going to be, this hasn't happened quickly. And to me, Ida, I think it's going to be the funders. As soon as funders say it has to happen, and if it doesn't happen, they want their money back, everything will change. Science, it's all about the money. And that's why the NIH is important. They need to move forward. We're trying to make a sea change, and that can't happen quickly, given all the people involved. But the quickest way to make it happen is for the funders to do something about it.
Yeah. Well, with that bottom line, I'll hand it back to Russ and Maya. And thank you all. I'm sure Russ will second this in a second, but really, really appreciate all the thoughtfulness and all the different perspectives you brought to this collective discussion. So thank you. So
Yeah.
Russ, Maya.
Here. And thanks, Steve, for your shepherding this discussion. I think it was really outstanding. And for me, it's one of the great things is, I don't spend a lot of time talking to people from the clinical realm, and so it's great to see how, people from different parts of the scientific world, are thinking either similarly or differently, or sort of viewing the relevant issues here. And I think it's been really useful for my thinking to kind of, get some cross-pollination between these different sides. It's funny because part of what my lab does is studies behavior change, and there's the iron law of behavior change is behavior is really hard to change. But I think we know that incentives are probably the most powerful way to change behavior. And so I think Jeff is certainly right that the figuring out how to get the people with the biggest incentives, i.e. the money, to figure out how to change behavior is going to be really important going forward. So I just want to thank you all again for joining us. I think it's been a really fun meeting, and hopefully you've all enjoyed it. And we will hopefully see you at our annual meeting again next year.
Thank you.
Thanks,
All right,
everyone.
thank